All right, let's begin. So, we are solving May-June 2022 Chemistry IGCSE Paper 2. So, question number 1. Were you able to solve this one? Okay, so which two gases will diffuse at the same rate at the same temperature? What should be the correct answer for this? Okay, and why is that? They have the same MR. To see which two gases will diffuse at the same rate, what do we have to do? We have to check. What's the key thing to solve this question is we have to check what? The MR of these elements or compounds, okay? Yeah, so those have the same MR will have the same rate of diffusion, correct? Very good. Next question, that is question number 2. So, so it's going to be A. All right, so for others also I'll explain this thing. So a student measures the time taken for 2 grams of magnesium to dissolve what 50 centimeter cube of dilute sulfuric acid. Which apparatus is essential to complete the experiment? So we have magnesium, we got the sulfuric acid as well. So this is in what, liquid form? Right. Okay. So this is in liquid form. We have this in powder form usually, or solid form. Magnesium is a metal. So to conduct this experiment, to make this magnesium dissolve in the sulfuric acid, what would I need? First, like you said, you're correct over here. The first thing that I would need is what? A balance. Why do I need a balance? So that I could measure the mass of magnesium that I'm taking, right? How would I know that the magnesium is 2 grams? Okay. So we need the balance to measure the mass of magnesium. I'll just write mg. Okay. Then what else do I need? I need the measuring cylinder. Right. Why do I need the measuring cylinder? For the volume. How would I know that the sulfuric acid is 50 centimeter cube? So for volume of H2SO4. Correct? Then the main thing that I would need is what? The stopwatch. I need to see how long does it take for the reaction to take place. Right. That's why I need the stopwatch as well. I won't be needing the thermometer because there's no work being done over here that is related to heat energy or anything like that. Okay. So therefore, yeah, very good. You're correct. The answer is 2A. Therefore. Now, question number 3. A chromatogram of a single substance T is shown. We got the solvent front, we got the baseline. Which measurements are used to find the RF value of T? So how do we find the RF value? Do you remember? Yeah. Can you tell me the formula? Which measurements are used to find RF value of T? Okay. What two things do I need for this? Yes. Very good. Very good. Very good. You're correct. So basically, we won't be needing this distance because you have to remember while we are finding the RF value, the distance is between the baseline and the solvent front. Okay. This is the major distance, the main distance that I need. This is the first distance that I need. This one. And then the other distance is this. From the baseline, where did I get the dye? At this point over here. So I need this distance. So this won't be the distance, this won't be the distance. I need just 3 and 4 to find the RF value. So where is 3 and 4? At D? Yeah, very good. So answer is D. Whenever we are finding RF value, we need the distance between the solvent front and the baseline and the distance traveled by the dye. Okay, from the baseline. Now question number 4. Let's quickly do this one. X and Y are two different elements. X and Y have the same number of nucleons. Okay, so the number of nucleons are same. What does that mean? The nucleon number is same, right? If it has the same number of nucleons. So which statement about X and Y is correct? They have the same physical properties. Their atoms have the same number of electrons. They are different in groups of periodic table. They have different relative mass. What about this one? Any idea how to solve this one? Yeah, yeah, they cannot have same physical properties. Yeah, very good. So, yeah, very good. If they cannot have the same number of electrons, okay, because the atoms have the same number of electrons. No, that's not possible. Then what else? What about D? They have different relative mass. Yeah, because relative mass is what the MR basically, right? Yeah. What else then? And they are mentioning over here, right? There are two different elements. Yeah, so that's why these. Yeah, yeah. So these three can never be the answer. Now they are in different groups of the periodic table. Yeah. So we are left with what? Part C. So that means this is what it means, right? When X and Y are two different elements, then only it means that they could be in different periodic table. They like in different groups. Sorry, I said periodic table. And they cannot have same physical properties. They cannot have the same number of electrons. Neither they can have different relative masses because their nucleon number is same. Okay, good. Question number 5. Okay, this is easy. Remember these structures? What are these? Which one is this, and this? Yeah, okay. First tell me about this R. What is R? It's graphite. Okay, good. What about this one? Diamond. And what about this one? silicon 4 oxide. So that means CQR. This would be silicon. Where is silicon over here? Between C and D. And then Q is diamond. Where is diamond? Okay, very good. So that would be okay. So did you choose C? Yeah, it is correct because this is the structure of what silicon oxide because of the two different atoms over here. Okay, and these two structures are made of carbon, diamond and graphite. The only difference is the structure, right? Remember, the graphite is in form of a layer. Okay, and yeah, and this is the structure of a diamond. So C is the correct answer. All right, now let's see question number 6. What does question number 6 say? Which dot and cross diagram shows the arrangement of outer shell electrons in a molecule of hydrogen chloride? How do we solve this one? They are saying we have to show the arrangement of outer shell electrons in a molecule of hydrogen chloride. So hydrogen chloride is what? HCl. Yeah. So how many electrons are there in hydrogen? Very good. So I can simply cancel out B and D. Correct, because this is showing way more than one electrons in both of them. So the answer is going to be either A or C. Now let's talk about chlorine. How many electrons are there in the outermost shell of chlorine? Very good. It's group 7. That means it has 7 electrons in the outermost shell and it needs 1 electron to become stable. So if you see this part, this is showing that the chlorine has only 1 electron outside. So this can never be the answer. So 1, 2, 3, 4, 5, 6, 7. Therefore, this A is my answer. Very good. Question number 7. The equation for the reaction between barium chloride and dilute sulfuric acid is shown. Which row shows the statement? Which row shows the state symbols for this equation? Okay, did you solve this one? All right, how would we do this one? We know this is what acid. It's gonna be aqueous. Very good. So where is aqueous written? A and C. That means I simply cancel out B and D. All right, now so between A and C, what's going to be my answer? Let's talk about HCl. What's HCl? Is this also acid? Yeah. And what about HCl? This is also acid, right? This is what hydrochloric acid. So it's also going to be what? Aqueous, of course. So where is HCl aqueous? It's liquid over here and it's aqueous over here, right? So that means my answer is going to be what? A. Very good. Got it? So we got the answer by using what? Sulfuric acid and hydrochloric acid. They both are acids and they are in aqueous form. Therefore, A is going to be our answer. All right, now let's see question number 8. Methane and steam react in the presence of a catalyst, CH4 plus H2O plus CO plus H2. 0.5 moles of methane reacts completely with 0.5 mole of steam. Okay, so we got the values as well for methane. Okay, 0.5 moles of methane react with 0.5 moles of steam, that is H2O. What is the volume of carbon monoxide, this, and hydrogen produced measured at RTP? Do you remember RTP? I remember I told you all the values for that you would use for RTP and STP, the difference in the values. Okay, so do you remember? If you remember it, can you tell me the values? And what about STP? Yeah, and what about STP? 22.4. So 22.4. We will be using RTP, so we are going to be using 24 over here for in the equation basically. How do we solve this question basically? Very good. Zero. Which would give us the volume. So the volume is going to be basically equal to what? Number of moles multiplied by the RTP, right? So that would be 0.5 into 24. What does this give you? It gives us 12. Okay, good. So this is the volume of at 0.5. This would be what? The volume of carbon monoxide, right? Because see, 1 mole of CH4 and 1 mole of H2O gives me 1 mole of carbon monoxide and 3 moles of this. So I'll be using just 1 mole over here. So that is 0.5. CO would be 0.5. Hmm. So, for example, let's say that first we get the value for H2, the moles that we are going to get for this. Okay. So see this. Take any one. Take either methane or water, whatever you want. Let's say I take water. So 1 mole of water gives me 3 moles of what? H2O. Sorry, hydrogen gas. So 0.5 moles of H2O will give me what? X moles of H2. That means X equals to what? 3 into 0.5. This is the main thing that I'm doing. Okay. This is the correct working. Remember this. This is how I get the moles for H2. Understood? Yeah. So what is 3 into 0.5? 1.5. Okay. So this is what I'm going to use now. For H2, my volume is going to be what? Moles multiplied by 24. What does it give you? 1.5 multiplied by 24. What does it give you? 6. So the volume for H2 is going to be 36. And the volume for carbon monoxide is going to be 12. Do you get it? And remember this working as well. See this working? Don't go for 0.5 and 24 and then multiply it by 3. Okay? This is the right way so that you don't do any mistake in your paper. So the answer is going to be what? 12 and 36. Where is 12 and 36? D. What was your answer first? D? Okay, good. Question number 9. A compound of element X has the formula X2O and a relative formula mass of 144. What is element X? Okay, now. How would I know what is element X? This is the relative formula mass, and I got the compounds formula as well. So what? Will you have the periodic table? Hmm. So you can use the periodic table in this one. What will be your answer then? We know that this is oxygen, right? What's the MR of oxygen? 16 plus. I do not know what this is, right? But I know that these are 2. So I write 2 into, let's make it X, and this is equal to 144, right? So 144 minus 16, whatever the answer is. What's the answer? 1 divided by 2. What is X? So we have to find which element in the periodic table has 64 MR. What is 64? Copper? Yeah. Yeah, so the copper is 64. The MR for copper is going to be 64. Okay, therefore Cu. Got it? Alright, now question number 10. The diagram shows the electrolysis of concentrated hydrochloric acid and concentrated aqueous sodium chloride using carbon electrodes. Okay, so we got these two. Okay, so at which electrodes is hydrogen produced? We have these two cells over here, this and this. At the left side, we got electrode 1 and electrode 2, and we have concentrated HCl. On the right side, we got electrode 3 and electrode 4, and we got concentrated aqueous sodium chloride. So, at which electrodes is hydrogen produced? Which one will produce hydrogen? Any idea? And remember, all these are made of carbon. These electrodes are made of carbon. So, you need to remember the reactivity series. Hmm. Hydrogen will go to the negative side, right? Very good. And okay, in on the left hand side, as hydrogen is positively charged, so it will go to the negative electrode, right? And over here, what about the second cell? Will I get hydrogen over here somewhere? See this? It is concentrated aqueous sodium chloride. Okay. Yeah. So, so between sodium and hydrogen, right? Chlorine is negatively charged, so it's going to go to the positive electrode. Okay. But then for the negative electrode, I got two options. Either sodium is going to go on the or is going to go on electrode 4, or hydrogen is going to go on electrode 4. So you need to remember the reactivity series. Okay. So therefore, who's going to go on electrode 4 between sodium and hydrogen? Hydrogen. And why is that? Why is sodium not going there? Because the solution is aqueous, right? You remember all those things that we studied in detail when we have a concentrated aqueous sodium chloride, when we have this simply concentrated sodium chloride, sorry, molten sodium chloride, and all other things, and the reactivity as well. So therefore, hydrogen is going to go on electrode number 4. Very good. Okay, so 2 and 4. That means 10D is the answer. Okay, good. 11. The diagram shows the electrolysis of aqueous copper 2 sulfate using inert electrodes. Which arrow shows the movement of electrons in the circuit? So this is cathode, this is anode. You need to show the movement of electrons in the circuit. Where will be the electrons flowing? Remember this electron flow in electrolysis is what? From negative to positive instead of positive to negative. Okay? This is what my conventional current. This is the electron flow or the current flow. So you need to remember this. So will it be from negative to positive? Right. Yes. So what is negative? Is cathode negative or is anode negative? Yes, the anode is negatively charged and the cathode is positively charged. So my current flow is going to be what? From A to B. Correct? So which arrow shows the movement of electrons in the circuit? Oh, they have made electrons. Okay, so they have made arrow. Yeah, this arrow is downwards. No, this is wrong. This arrow is to the right. No, this is correct. Right? Okay, so 11, B is going to be my answer. Okay. Then question number 12. Which row identifies a chemical change and a physical change? Okay, so do you remember chemical change and physical changes? Okay, so why? They are saying which row identifies a chemical change and a physical change. You need to remember one thing. We burn something. Okay, whenever we burn something, what does that do? It creates a new element for us. So whenever there is a chemical reaction, it usually involves burning, right? To break up the bonds, to break up any two compounds, all right? So this is one major thing. So look for burning. Where is burning written? On A, on B, and on C, right? These are the three options where I can see burning written. Now, is evaporation is a chemical change? No. It's just change of state of matter. Is dissolving ethanol in water a chemical change? No, it's a physical change. This is a physical change. This is also a physical change. So D can never be the answer. Now, what else? Like I said, burning is what? Burning, whenever you see the word combustion or burning, that means what's going to occur? A chemical change or a chemical reaction. So it is representing chemical. Where do I see burning written over here? On the physical change part, right? So I simply cut this down as well. Where else do I see burning written? Over here. Again, I just told you it's a chemical change. It's a chemical change. So I cancel out this as well. What am I left with? See what are they saying? Burning ethanol? Yeah, it's in the right column. It's a chemical change, and evaporation is obviously a physical change. So what's going to be my answer? D. Oh, sorry, B. 12B. All right, let's. You got this wrong? It's fine. It's fine. Do you get the value and the concept now? Okay. Whenever there is whenever there is evaporation or boiling or melting, those are all what physical changes. What else now? Question number 13. Which statement explains why increasing the concentration of a reactant increases the rate of reaction? Okay. Which statement explains why the increasing the concentration of a reactant increases the rate of reaction? Okay. If I increase the concentration, it eventually increases the rate of reaction. Why? They have given us four options. Because it increases the collision rate of the particles, it lowers the activation energy, a great proportion of colliding molecules have the required activation energy, and four, there are more particles per unit volume. That's why the rate of reaction increases. What's going to be the right answer for this one? I hope you remember our lectures. Remember when we were talking about collision, we studied about the collision theory. Okay, so is this justifying the collision theory and increase the collision rate of particles if I increase the concentration? Simply, they would collide even more. The chances of collision would drastically increase if I increase the concentration of the reactant. Correct? So this is helping me filter out my options. So one is definitely going to be part of my answer. So where is one written? It's written on A and it is written on B. So I simply cancel out C and D because one will definitely be part of my answer. Now what am I left with? They are giving us 3 and 4. Let's have a look on 3 and 4. A greater proportion of colliding molecules have the required activation energy. Is this why when we increase the concentration of reactant, it also then eventually increases the rate of reaction? Is this the reason? Or is it that as we increase the concentration, what does that give me? It gives us more particles per unit volume. So because of this, more collisions occur because there are more particles in per unit volume than they were before. Do you understand this point? So the space is the same and the particles have increased by increasing the concentration. This is what they're basically trying to say. So which one is more justifying, 3 or 4? Yes, it's going to be B because we already talked about the collision theory over that it increases the collision rate of particles. The greater proportion of the colliding molecules have the required activation energy. No. So this is going to be my answer because there are more particles per unit volume. The space stays the same. The particles were less before. I increase the concentration, so the space is still the same, but the particles have increased drastically. So what will happen? They will collide even more and provide a rate of and provide an increase in the rate of reaction. So my answer is going to be correct. Okay, do not forget this one. It's going to be B. All right, question number 14. When the colorless gas N2O4 is heated, it forms the brown gas NO2. When the reaction mixture is cooled, the brown color fades and turns back to colorless. Which type of reaction is described by these observations? So when the colorless gas N2 is heated, forms the brown gas NO2. When the reaction mixture is cooled, the brown color fades and turns back to colorless. How do we solve this question? Very good. As it was colorless before, and after heating it up, it has when it cooled down, it became colorless again. So therefore, it is what? A reversible reaction. Very good. Okay, now question number 15. Water is added to anhydrous copper sulfate. What happens during the reaction. Remember hydrous and anhydrous? You have to this one is memorization part. Remember that chapter, you have to memorize this the color pattern of it, okay? So anhydrous means what? It does not include water in it, right? It's in its powder form, remember? The copper is in its powder form. Whenever it is in its powder form, we say it is an anhydrous copper. And when we add water, it becomes hydrous, right? So when we add water, it changes color. And when there is no water in it, it is white in color or blue in color. What's the color of it in anhydrous form without water? You need to properly memorize all these things, okay? Without water, it is blue in color? No, it's not. When it is in anhydrous form, it is yellow in color. Oh, sorry, it is white in color, no? Right? And when we add water to it, then it becomes blue. Okay? So I have to see where is it turning blue because it is in anhydrous form. It's going to change from white to blue. Okay, so where is it written? It turns blue. Okay. And the solution form gets colder. Okay. No, it does not get colder. And then they are saying it turns blue and the solution gets hotter. Yes, this one over here. The solution becomes hotter and it turns from white to blue. Got it? These are both white, so these can never be my answer. All right, now. Question number 16. All right. Which arrows on the energy level diagram shows the overall energy change from the endothermic reaction? All right, okay. Which one shows the endothermic reaction? It's going to be B because this is the change, right? And if this was exothermic reaction, then what? Then the reactant would have been above and the product would have been right. And the product would have been below in exothermic. Good, 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 good. So the answer is going to be B for 16. All right.